Now, what we're going to do today, year 10, when you're ready, is we're going to look at really sketching these parabolas quickly, because we have a vague idea of what they're meant to look like, right? Concave up, concave down, they can have X and Y intercepts. But I really want to think about how can I sketch the features that I need. And what I have here is something called essential features, right? When I'm asked to sketch a parabola, these are the things that I always need to have. Question mark.
What about concave left and right?
That's a really good question. You will do that in year 12. I'm glad you asked that. You can have concave left and right parabolas. So, but I don't know what's a good way to remember those, but we'll have a think about it. All right. What do we need to include? Well, the things that we need to include, actually the only things we need to include are X-intercepts and Y-intercepts. Those are the only things we really need to include in a parabola. What they can do though, they can actually ask you to sketch more. What else? What other features of a parabola have I not mentioned? What do I call the line? I don't want to use the line. The axis of symmetry, good. And the axis of symmetry actually allows you to find something else, if you remember. The vertex, good. The vertex. Well done. Now, it should be vertex, not the things that you throw. It's a vertex. Okay. But I want to say something in particular about this vertex, right? Because we can actually have a few types of vertices, right? If you think about the concavity, you can have concave up and concave down, okay? How do I know when they're up or down? What about these vertices? Because we have different types here, right? If I have something that's concave up, what I'm looking for is the coefficient of x squared, so the number in front of x squared. If that's a positive number, then I'm concave up. So I'll look like this. That vertex, that's actually going to be a minimum. Okay, so it's the lowest point. That's a minimum vertex. But if I have a concave down parabola, right? So it's facing down, it's a sad face, it'll look like this. It's right. I'm going to have a maximum. These are the things I want to think about when I'm trying to sketch these parabolas. I want to think, okay, what are the X and Y intercepts? I want to also note the concavity, and if requested, I want to know the axis of symmetry and the vertex. For these ones, I'm going to get us to sketch all of those, but unless they specify, really only these two are required. Okay? Let's just do this first one together. Okay? First of all, X and Y intercepts. How do I find those again? Well, I need to think, all right, for X-intercepts, for X-int, I want to let Y equal to 0. And for Y-intercepts, I just swap it around, right? I say, let X equal to 0. Now for this one, because it's in a factorized form already, it's actually really easy to tell what are the X-intercepts going to be. What are they going to be? Can you see that, right? Remember, if I'm saying, okay, for X-intercepts, let Y equal to 0, of X minus 3 and X plus 2, you're essentially saying, okay, what value of X do I need this to be so that this equals to 0? What value of X do I need this to be so that X equals to 0? What's on the other side there, right? If X equals to 3, you would get 3 minus 3, which is 0. Or if X equals to minus 2, then this side would be equal to 0. Right? Does that make sense? Right? Because if I have things in a bracket like that, if one of these is equal to 0, then that whole thing is going to be 0. Okay. What about for the Y-intercepts? Well, similarly, it's actually quite easy, isn't it? If I say Y is equal to 0 minus 3 or 0 plus 2, what's that going to be? What's Y going to be? Maybe if I write it like this a bit better. What do I mean when I have these brackets here? When I have these brackets? Remember, what operation is there? Multiply, right. So minus 3 times 2 is? Minus 3 times 2? Minus 6, we got there. Okay. Okay, let's put all this information together. Shh. Almost there, guys. Let's put all this info together. I've given you guys some graphs. What I would do, year 10, what I would do is, I would start off by drawing the X-intercepts, okay? So I know I've got X-intercepts at 3 and minus 2. I also know I have a y-intercept, don't I? Right? Y-intercept of -6. What kind of concavity is this parabola going to have, do you reckon? Concave up, right? Because if you expand this out, remember, I can actually only tell the concavity if I look at the coefficient of x squared here, right? This one I haven't actually expanded it out. I could do that. It would just be x squared, what would that be actually? Minus x minus 6. Okay, so if you expand it out, you get something like this. You're saying, okay, what's the coefficient here? What's the number in front of x? Well, that's 1. That's a positive number. Okay, so I know it's going to be a concave up parabola. It's going to be happy face. All you need to do here is it's kind of connect the dots, right? Because you have these main points here. You've got the x-intercepts, and you've got that y-intercept there. What I want you to be careful of, though, is it's actually sometimes useful to find the axis, because remember, the axis will tell you where, in this case, where the minimum point is. Okay, so I know the y-intercept is here, but I actually don't know how low the parabola goes. Right? Where would the axis be in this case? Well, you can either use minus b on 2a to find that, or what's an easier way in this situation? You could just say, what's halfway between -2 and 3? Yep, 1. Is that right? Yep. Is it 1? -2 plus 3 on 2. I think it's a half actually. Yeah. So if you want to find the average really quickly, just add them together and then halve them. So I should find the axis is at half, right? So I know I've got an axis here. I did my best. How do you find the minimum though? How do you find the minimum? This is where the axis is at x equals to -1/2. How do you find the y coordinate of this though? So what am I trying to do? I'm trying to find, I know where the axis is. I know where the halfway point is. But I want to know how far does it actually go on my parabola? Okay, right. This is the power of coordinate geometry, right? If I know that the parabola exists at x equals to -1/2, all you have to do is go back to the original graph. If you put in that x value of a -1/2 back into here, you always get the y coordinate. Does that make sense? Right? Anytime you're saying, okay, I know that the parabola is going to be at x equals to -1/2, if you want to find out what the y coordinate is, you can just go back to this graph and then put it straight back in. So what I would write to do that is I would say when x equals to -1/2, y would equal to, and you can just put it back into your calculator. You don't have to actually write this out, but you can just put it in your calculator. Plus 2. Can you guys put that in for me? So chuck this guy into your calculator for me. Oh yeah, I haven't. Oh, sorry, that's meant to be concave up, concave down. Can you guys put this in your calculator for me? Tell me what you get, and then I'll just recap what we've just done. Yeah, Harry. Oh, sorry, it should be positive half. Thank you. Try that again, sorry. Positive half. $6.25? Yeah, minus 6.25. What's that as a fraction, by the way? Okay, let's just recap what just happened there, year 10. So, I'm trying to sketch these parabolas, and I know that there's all these features there. The hard part is connecting it up and trying to actually put it all together. Just break it down into steps. We found the x and y intercepts, so I've already got those, -2 and 3. I've got the y-intercept, that's -6. Now I want to know the axis and the vertex, in this case the minimum, right? And to do that, I found halfway between the x-intercepts. That gives me the axis there, I've got that. The last step I need to do, once I've got that, is I put it back into the original equation so that I can find how far down it goes. And I found that. It goes down to about -6.25. So it actually goes lower than this. So I know that the vertex should occur at here. Half and -25 on 4. And then all I have to do now is I'm just going to connect it up. I know it's concave up. So it should look something like this. Okay. So that's our parabola. Okay. I've found all those features, and then I've connected those points to sketch it. Let me just do the next one with you guys, just to get the process, and then I'll let you try the rest yourselves, all right? So let's come back. First things first, Corey, what kind of concavity would this parabola have? Good. I look at this coefficient and I say, it's a positive 1. As Corey said, right? This is going to be concave up parabola. I'm expecting it to look something like this because that coefficient of x squared is just a positive 1. Then I want to go through that whole process and I want those essential features, right? I want to find the x-intercepts. I want to find the y-intercepts. Right. May, how do I find x-intercepts again? Awesome. Let y equal to 0. Right? And so literally I'm just going to say y. Instead of a y, I'm going to write 0 equals to x squared plus 7x plus 12. In this case, you notice it's slightly different. We have to do a bit more work here. It's not factorized. So can you see how factorizing is such an essential skill here? Because if it's not in the brackets, it's very difficult to tell what values of x are going to make this 0. What should I do here, Joel, to factorize this one? What should I do here to factorize it? PSF, right? I'm saying, what's the product? 12? What's going to sum to 7? I want two numbers that do that. 3 and 4, right? 3 and 4 are going to be my numbers. So 0 would equal to x plus 3, x plus 4. Why doesn't 5 and 2 work?
I was just joking.
Haha.
Multiply together.
Good. Now, here's what I'm actually interested in. I'm saying, okay, what's the actual solutions to this? So what values of x will be equal to 0? That's right again, right? You're saying, what values of x will make this expression equal to 0? If you want to think about the long way again, you just block it off and say like this. X plus 3 equals to 0. Well, what would x equal to? X would equal to minus 3. And then I also have this side. What about x plus 4 equals to 0? Well, x would equal to minus 4. Those are your x-intercepts. That's where the graph crosses the x-axis, right? What about for the y-intercepts? Well, similarly, I'm just going to let x equal to 0. Okay? It's actually easy in this form. You can see what y is going to be. It's just going to be, yeah, right, because these are just all going to go away if this whole thing is 0. So y would equal to 12. Awesome. Almost there, guys. So I've got those x-intercepts. I've got that y-intercept. So minus 3, minus 4. It goes down quite low. Here's a tip when you're sketching these, okay? When you're sketching these, the scales, they don't have to necessarily reflect that. You don't have to have it so that it reflects that the x and the y axes are in scale with each other. You can just kind of have that up there in some place. Okay, so I've got all these points here. Where's my axis going to be in this one?
3.5.
Negative 3.5, right? Because remember, where does the axis occur? It happens halfway between these guys, right? Halfway between negative 3 and negative 4. That's where my axis is, right? Now remember, the axis isn't actually a part of the parabola, but it tells me where's the halfway point, right? So that's why we represent it with a dotted line. So negative 3.5, I've got my dotted line going like this. Okay. What's the last thing I want to find? Vertex, right. In this case, it's going to be a minimum. And remember, to find the vertex, to find this bottom point of the parabola, if you have the equation for the axis, so in this case, x equals to negative 3.5, to find where that vertex actually occurs, so the y-intercept of that, right, all you need to do is substitute it back in to your original equation. That's how you do it. That's how you find the y-coordinate of the vertex, right? So remember, the vertex, I'm just trying to find that lowest point where the parabola goes. So, and this is how I'll write it out. I guess you can say to find vertex, when x equals to negative 3.5, you want to put it back into this equation here. What's y going to equal? Can someone put it in for me? Is it minus 1 or 4? Okay, yeah, sure. Question, Maddie, yeah. Shh. Yeah.
So when you're finding the vertex,
Yes.
you need where the axis of symmetry is, and wait, so you put it back into the
Into this.
I agree.
Right. So look.
Wait, do you
Yeah.
turn that back into y equals that, and then you're finding y?
Yeah, so let's just think about what, I think this comes really back to what coordinate geometry is, right? If you're a bit confused about that whole process, I think you need to go back and actually examine like what coordinate geometry represents. We have x's and y's here. Those reflect where the graph is on your Cartesian plane, right? What I'm doing here is I'm saying, I know that the graph exists at x equals to minus 3.5, because that's where the axis is, that's the halfway point. So I'm saying, at x equals to minus 3.5, right? I'm saying, where's the y coordinate going to be? That's actually what you're trying to find, right? And exactly as you said, you say, when x equals to minus 3.5, I want to substitute that back into here, and I'm going to find a y coordinate. That's actually going to be the coordinate of the vertex. Does that make sense? Right? So that whole process is, I need to find the vertex first. That's x equals to minus 3.5. When I put it back into this original equation, which is the equation for my parabola, then I'm going to find the y coordinate at that point. That's at negative a quarter, apparently. So that's my last point that I need. And then again, just connect the dots. Woo. Just like that. And by convention, what we will write is, at that vertex point, you can either write these points here, or you can say that coordinate is negative and a quarter, negative 7 on 2, which is just minus 3.5.